Now let's have some fun with IP version 6. IP version 6 is 128 bits long, and you see 128 bits all strung out here. Now we can separate these into 16-bit chunks, and we're going to separate them with a colon, and I've also changed the color of each section just to make it a little bit easier to identify them. But we have 1, 2, 3, 4, 5, 6, 7, 8 of these sections. Now we're going to translate each of these 16-bit sections to hexadecimal. Hexadecimal has digits from 0 to 9 and then A through F because there are 16 possible combinations. So we have here 2001 DB80 12EB 0000 FE77 over here, 0000 again here, 1371 7334. Now we're going to call each section a hextet, hex being 16. So for every hextet, for every 2-byte section, if we were to translate that to decimal, we would get from 0 to 65,536 possible combinations within one section. So in order to find out the total number, we simply multiply that by itself 8 times, and we're going to come up with a number like this: 340 undecillion, 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, 463 quintillion, 374 quadrillion, 607 trillion, 431 billion, 768 million, 211,456 possible combinations. Now let's take that same calculation we did with IP version 4 and divide it again. With 7.5 billion people in the world, we divide it out. We divide this number by 7.5 billion, and we get about 45.9 octillion addresses per person. Almost 46 octillion addresses per person. This guy here, Steve Liebson, I gave the reference here, puts it this way: we could assign an IP version 6 address to every atom on the surface of the Earth and still have enough for about 100 plus Earths left over. So it isn't remotely likely that we'll run out of IPv6 addresses anytime soon. So the upshot is, unlike IP version 4, we are not out of IP version 6 addresses, and we're not going to run out anytime soon, if ever. All right, thank you for your time.